So it's been a minute. I put these videos up 2 years ago when I had to put my class online for COVID, and I was not expecting many more than just the students I was directly teaching to be interested in them. But it seems that there is some more interest. It seems that there's a lot of people around the world learning computer science, and particularly the architecture of computer science, and particularly from the ground up, the bits and bytes and pieces and processes that you need to build a computer from scratch. Every computer science program around the world has this course as part of their main curriculum, and everybody teaches it differently. I hope the work that I'm doing here can be somewhat useful to some of the folks that have been trying to learn this in a few different contexts. The way your instructor teaches it is the right way to do it, because that's who's going to be giving you the marks at the end of the day. But I've been teaching this stuff for a while, and I like to think I've got a unique take on it. So I'm going to continue. I'm going to start to make a few more videos. I'm going to start with teaching you ARM, the ARM assembly language, particularly ARM v7, because that's the one that I have worked on. The current version of ARM is ARM v8, and it's significantly different than v7. Version 7 is really interesting. They've got some really clever design methodologies in there. But if you're not learning ARM v7, that might not be that useful to you. Maybe it will. I'll build a set of slides on this for ARM v8 as well. And if you are learning how to write that assembly language, then that's great. It's the assembly language that we find in most of our mobile computers these days. Our phones and our laptops and stuff is all ARM all the time. In addition to that, I'm going to do sort of the second half of the course, the second half of the architecture course, which is once you've built a basic computer, how do you do things like memory, cache memory, memory hierarchies, virtual memory, translation look-aside buffers, cache coherency, multiprocessing, all that kind of awesome stuff. Then the other sort of big topic is input and output, which involves things like networking, communication protocols. How do you get information into the machine? How do you get information out of the machine? And how do you make sure that all of these processes can synchronize? Then we look at optimization techniques like superscalar, pipelining, and multithreading. All from the context of how do you take the basic machine and make it better? How do you make it faster, given the kind of constraints that modern programming places on it? Then we get into higher level stuff like parallel processing, GPUs, and distributed computing, all sorts of neat stuff like that. I also take a minute, because most courses do this, to discuss performance. Things like Amdahl's and Gustafson's law. How do you judge whether the improvements that you make to a particular piece of hardware in fact improve the process enough to make it worthwhile, cost effective? And how do we measure performance? How do we decide that one machine is better than another? And how have certain parties in the world, say, manipulated some of these measures and benchmarks and things like that? The other thing that we will talk about is hardware security. How some nefarious actors have used hardware, exploits in hardware to implement bugs and bad action, shall we say, in the context of computing hardware. Some of the biggest, most nefarious kind of bugs and the kind of fixes that you've needed to implement when these bugs have been identified. So a lot of neat stuff, and I'm hoping that I'll just be able to sort of build on this topic by topic as we go. If you're interested in this stuff, great. If you're not, no big deal. If there's stuff that you think that you would like me to show you that you haven't seen yet, let me know. The videos that have seen the most traction so far are the K-map videos, the solving of Carnot map circuit design problems. If you want to do more of that, I'm happy to do as much of that as you like, because I think it's interesting that people have connected with this channel a little bit, and I don't know what I'm doing. I mean, I watch YouTube and I see some of the things people have done. I'm not going to go whole hog like that, but if I can be of service to the community, if there's things that you want to learn that I can teach, then I am excited to do that for you. So let me know what you want to do. And if I hear nothing, I'll just proceed with the second half of the architecture course as it is and build from there.